talking about exponential functions, and we talked about exponential functions. When you look at the y values, they multiply by the same thing every time. Sometimes you have a table, you might not see that it multiplies. For example, if I look down here, 7 times, there's not a whole number, but if I do like 13 divided by 7, I get that. 25 divided by 13, we're not multiplying by the same number every time. But this could still be an exponential function. And the reason that we don't see that common ratio, that number being multiplied, is because it has a vertical translation. So sometimes you have an exponential that's shifted left or up or down. And so you would not see, you won't see that common number. So what you do is you look at the table and you have to figure out how it's shifted. This is a kind of a guess and check. We want to figure out what number that I could add or subtract to these y values that would lead me to have a common ratio. You just gotta look at them and play around with the numbers. So I'll give you this one. If I subtract 1, I'm gonna extend this table out. If I take my f of x, if I subtract 1 from all of those numbers, this would be 6, 12, 24, 49, 48, and 96. Now do you see a common number being multiplied? What's it multiplying by? 2. It's multiplying by 2. Like 6 times 2 is 12. 12 times 2, all of those are times 2. So it is exponential, it's multiplying by 2, but it's also being shifted. And so the way that we come up with the equation for this is we start with the equation for this one, the one that actually has that common ratio. In exponential functions, y equals a times b to the x. A is always like your zero term. It's your zero term. We started with geometric sequences and comparing them. It was always your zero term. B is like your ratio, what you're multiplying by. So what we're going to do is we are going to come up first with the equation for that one. So I'm going to call this is just f of x minus 1. Okay. My zero term, it's the y value. It's the y value when x is 0. So if I'm looking at my translated, my green, what is the y value when x is 0? When x is 0, what's my y value? Of the translated one, 6. So a is 6. B is my ratio. So what am I multiplying by here? 2. So I'm going to write an equation for this translated one. And I'm going to call it f of x minus 1 because we subtracted 1. That's equal to 6 times 2 to the x. So I subtracted 1 from all of those. So I called it f of x minus 1. And then that's equal to 6 times 2 to the x. And now if I want to get f of x by itself, I would add 1 to both sides. And this equation is what would give me this table, the original f of x that I started with. So if I go to y equals 6 times 2 to the x minus 1, or plus 1, and I look at the table, 0, 7, 113, 225. So that's how you get the equation that corresponds with that. So let's look at another one. Starting out, I'm like, okay, well 2 times 5 is 10, but 10 times 5 is not 34. So it's been translated. I'm telling you it's exponential. You've got to figure out, okay, well what is that? So any ideas of what I can do to g of x to then see a common ratio? Sometimes you just have to play around with numbers in your head. Try adding a number, subtracting a number to the y values. That's it. If I take g of x and I add 2 to all of those, this would be 4, 12, 36, 108, 324. If I multiply 4 times 3, I get 12. What's 12 times 3? 36. What's 36 times 3? 108 times 3 is 324. So by adding 2 to all of those y values, I got a common ratio.
So how did you get 2?
She just looked at she just played around and probably said, okay, well what do I get if I add 1? No, that doesn't work. What if I get if I add 2? Oh, look, that works. You've got to just try out numbers. To the y values. So like, let's just say I just wanted to play around. What if I added 1 to the numbers? Okay, this one would be 3, 11, 35. Is there a common ratio there? No, there's not. Okay, yeah. So she's just like, well, let me try 2. I'm not going to give you one probably where you have to add 27. I think all the ones that I've seen in the practice are like adding 1, 2, 3, small numbers. So it might take you a minute. You might have to try subtracting them. You might have to go through like I did. Try something. Nope, that doesn't work. Mark it out. Try something out. No, that doesn't work. Mark it out. Okay. And so now, this g of x plus 2, it's super easy to come up with your equation when it's a nice ratio, when you have the 0 right there. Okay. So for this one, the g of x plus 2, what's my 0 term? 4. Because the y value when x is 0 is 4. And then what's my common ratio here? 3. So 4 times 3 to the x is the correct equation to this g of x plus 2. But I want g of x by itself, so I'm going to move that 2 over. Minus 2. Like that. And so this equation right here is the equation for the original table that it gave you. Okay. So like if I plugged in a 1 for x. 3 to the first is 3 times 4 is 12 minus 2 is 10. So that's where it got from. So look at number 2. What can I do to these y values to have a common ratio? Plus 1? Yep. So h of x plus 1. If I add 1 to all of these y values, 64, 32, 16, 8, 4. What's happening? What pattern is happening here? Times what? 1/2. Times 1/2. It's dividing by 2, which is multiplying by 1/2. Your ratio has to be what you multiply by. So 64 times 1/2, or 64 times 0.5, is 32. So my equation to h of x plus 1. So the equation that I got when I added 1, my 0 term is 64. My ratio is 1/2 to the x power. So we need to move this 1 to the other side. That right there would be a multiple choice question on the test. So, if it's multiple choice on the test, you can look at these numbers over here as a guide to what you should try out if you get stuck. Or just plug in one of the x values and see which one works. Like that works too. Alright, now the other thing we're going to get into is something that we have talked about. It is regression. Basically, regression in your calculator, regression is it just gets an equation in the calculator. So you can use a calculator if you have a table of points to get your equation. You will have to do this on an FRQ, like they've told us. You will have an FRQ, so when we've learned enough content to practice FRQs, we'll start throwing those in next semester some. But so you've got to know how to do this. This comes up when you're going to have questions that are real world data. Real world data is not ever perfect. When you collect data for something, it's not going to be a perfect pattern. But the calculator will get a good graph to fit that. It'll get as close as it can. In Algebra 1, you talked about line of best fit. That's basically what it's doing. So you're going to have a data set, a table, where you've got x and y's. And so in your calculator, you're going to put all those in, and we'll practice doing that. So you really basically just have to have at least 2 points. Okay? So let me just show you how to do that, because it's not on here. So to get to your lists, you have to hit the stat button, and then it's number 1, edit, and those come up. If you have numbers in your lists, so if you want to clear out your lists, gotta be careful. you have to highlight like L1 if you're gonna clear it. So highlight L1 and then hit the clear button. It's really important that you don't hit the delete button. And then you hit enter. That's the quickest way. If you have a whole bunch of numbers, you actually highlight L1, hit clear. So let's see if I have like 1, 2, 3. Highlight it, hit clear, and then hit enter. And it clears it out. If you hit delete, list 1 goes away, and then I forget how to get it back. But I can figure it out. So, number 3. Selected values of the exponential function g are shown in the table below, where g of x is a times b to the x. It's just telling you the equation of an exponential. Write 2 equations that could be used to find a and b. So if we had to do this by hand, we're going to write 2 equations. We're going to put a 3 in the x spot. We're going to put a 21.54 in the g of x spot. So equation number 1 would look like this. 21.54 equals a, b to the 3rd. And my other equation is 3.62 equals a times b to the 8th. That's all you could have done to figure those out. You actually don't have enough information to get these really on your own without a calculator. Because you don't have the zero term, and you only have 2, so like your ratio, like you would have to do the root. I don't even know if this would work out. This would be the 5th root of 3.62 divided by 21.54, and you get that decimal. So it's not even a perfect ratio. Okay, so it wouldn't really work. But if it says write 2 equations that could be used, that's what it's asking for. Now your calculator is going to give us a true equation that would pass through those 2 points. So we're going to go to Stat, Edit, and we're going to put in these 2 points. 3 and 8 are my x values. 21.54, 3.62. If you have 2 random points on a coordinate plane, I could draw a straight line through those. I could even make a quadratic go through those. I could make an exponential go through those. So your calculator will write whatever type of equation that you tell it to. So we've got it in. We're going to go back to Stat, and then we're going to go over to Calc. And you can see right here that Calc is highlighted. And we want it to do an exponential because it said exponential in the function. So I'm going to go back to find the EXP regression. It's going to write an exponential equation for us. Okay. Got that. List 1, list 2, so that's my x's are in list 1. My y's are in list 2. That one doesn't need anything. The store, you need to store it in y1. What that's going to do is it's going to type that equation into y1 and make our life easier later on. So to get that, you might want to make a note. To get that, it is, let me double check. Yes, it is alpha trace. Alpha trace does y1. And then we're going to hit calculate. So that's my equation. It's big long decimals, right? So y equals it says A times B to the X, and it tells us what A and B are. So when you're writing out the equation, write 4 decimal places. Here's what they've told us. Yours has to be correctly rounded to 3. But if you put 4 or 5, you're safe. And if you mess up rounding after the 4th or 5th one, it's okay. They're only going to pay attention to the first 3. So always write 4 or 5 decimal places. So 62.8012 times 0.69999. The more you write, the safer you are, to the X. So that is the equation. Now, see how it's in y equals? And I didn't have to type it in. It's all there for me. Because you will probably, on an FRQ, you will be doing things with this. You will be finding different things. And then you don't have to keep typing it in 100 times. So, moving on. The data below gives the amount Mr. Kelly owes Mr. Sullivan each year after he loses in fantasy football. No payments have been made, so Mr. Kelly's debt grows each year with interest being applied. Anytime you've got interest, it's going to be exponential. Number 4 says, use an exponential regression to model this data. So we're going to go put these in our list 1, list 2, and find the exponential equation. So go back to Stat, Edit. 1, 2, 3, 4, 5, 12, 20, 59, 109, 267. Once you've typed in the numbers, go back to Stat, go over to Calc, and it's exponential, so we're going to find the EXP regression. List 1, list 2. I don't know. I wish you could make it automatically have Y1 there. It automatically has L1 and L2, but I don't know why it doesn't. And then you hit enter, enter. And there is our equation. Y equals 4.93950 times B 2.20346 to the X. Using the model, predict how much Mr. Kelly will owe Mr. Sullivan in year 7, assuming the pattern continues. Your years are your X values, which means the 7 is going to go in for the X. So I'm going to do 4.939, and I'm going to, just for space, I'm only going to put 939 here. But when you go to type it in, I'm going to show you how you type it in real easy and it doesn't round. 2.203 to the 7. My equation is in Y1 because I told it to store it there. If you go to alpha trace and hit Y1, and then beside of that in parentheses you put a 7, it's going to put a 7 in all of the X's for whatever equation you've got in Y1. It's like the store button, but even better. And so this is an amount of money. Money is always 2 decimal places. So 1245.73. That's about how much money. Any questions on how I got that? If Mr. Kelly loses every year from now on and refuses to pay Mr. Sullivan, in what year will Mr. Sullivan be owed $5,000? So we are setting this equation equal to $5,000. 4.939 2.6 equals 5,000. You have not learned how to do this algebraically. A question like this, you will have your calculator. So I'm going to show you how you can do it in your calculator. And it's not too bad. So you're going to go back to your y equals. What we're going to do is we're going to put 5,000 in y2. Because that's what it's going to be set equal to. And we're going to graph it, but if you hit the graph right now, you're not going to see this second line because it's at 5,000 and our window goes to 10. So we have to change the zoom, and if you go down to 0, zoom fit. Most of the time, this is a good starting place. The calculator tries to fit the data. It tries to fit your equation. It doesn't always work. But sometimes it, geez, people. It's a sink. I don't know. No. Right. And what we're going to do is find, I need to fix that too because that needs to be black. Let's try this again. We're basically going to look for the point where those two cross. We're going to find the intersection of them. Not using just the trace button because that will not get us very accurate. Okay, so we're going to put into Y2 and then we're going to graph. Okay, and then we're going to do second trace.
My calculator did not do that and now it's spinning.
Hold on, let me look at it.
It won't do anything.
You hit the enter button and that paused it. Is it going now?
Yes.
Okay. So see above trace where it says calc. That calc will do some calculations involving the graph. So if I hit second trace, it'll find specific things. We want to find the intersection. We want to find where they intersect. Okay. And it's asking me first curve. It's in case I have like 20 different lines in there, it needs to know which two I want. So first curve. If it's on the blue, if it's got letters in blue, it's on that one. Hit enter. Second curve. See, it jumped up and it showed red. Hit enter. Guess. Why your calculator wants you to guess, I don't know. You can move your cursor close to where you think that the intersection is. I think you can hit enter wherever it is. I don't know. I don't know why it does that. And then it gives us the intersection. The y value is 5,000. The x value is what we were looking for, the number of years. So approximately 8.759 years. Yeah, probably. And it asks in what. Oops. We get 148.8982. average rate of change. You subtract your y's on top, you subtract the x's on bottom. Here's something that we were told. If you have this on a like FRQ, they will not give you credit if you don't show that fraction. They have to see that. So we're going to make sure that we always put it. And now your fraction, you kind of have two options. You can put these full numbers, or you can put just b of 1. But it's easier like to think about it if you put the full numbers. So we're going to subtract the y values on top. 23.1782, I'm just going to put that, minus 148.8908 over, then subtract the 1 minus 7. See what I did there? Instead of actually typing those numbers in, I went up and highlighted them in my calculator and hit enter, and it brought it down to my fraction. And now I know that's more accurate than what I have because it's got more decimal places. And it saved me some time. Equals 20.9521. All right. The next thing, you might see something about a percentage increase or a percentage decrease. This kind of has a formula to it, but it's something we've talked about. For example, I told you when you have sales tax 6% and you're calculating that, you do like 1.06. If you have a $10 shirt and you want to find out what you're paying for that after sales tax, you don't take the 10 times 0.06. You do 10 times 1.06. That's what this is. So when you say something is growing or increasing at a rate, a percentage rate, like it's increasing at a 2% rate, it's exponential. Y equals A. Your B comes from that percentage. It's your rate, your ratio. You do 1 plus the percentage to the X. So if it's a percentage increase, you add that number to 1. And that's your ratio, or your rate, your B. So for example, a home's value is $200,000. It increases by 1.5% per year. And we're going to write the function. Well, you need this to be a decimal. So 1.5% is the same as 0.015. And then my function would be y equals, A is your initial value. So in this case, it is what? What's the starting amount of my house? 200,000. And then my B is 1 plus 0.015, which is 1.015 to the X. Percent decrease is you just subtract the percentage off. So like when you go to the store and something is 10% off, you multiply by 0.9 because you're losing 10%. You started at 100, you're losing 10%. So you do the 1 minus the 0.1. So percent decrease, y equals a times 1 minus the percentage to the x. Mr. Smith's yard is getting overrun with weeds. The first year he bought his home, there was 180 square feet of grass. It is decreasing by 28.1% per year. So we're starting at 180, we're losing 28.1%. What is this as a decimal? It's 28.1% as a decimal. 0.281. So y equals, we're starting at 180. We have to do 1 minus 0.281 to the x. And we will, I'm going to come back to this. I'm going to do an example. Let's do 7 and 8. Surfside High School was built in 2007 and has a growth rate of 1.8% each year. The initial student population, it tells us A0, that's the initial amount, is 1,483 students that year. The variable t equals 0 represents 2007. So 2007 was the very beginning, 1,483 students, growing at 1.8%. So, write an exponential model to represent the scenario. So, we have y equals a b to the x, that's exponential. A is your initial amount, which is what? $1,483. B is your rate, or your ratio. Now it's growing at 1.8%. So am I going to add or subtract from 1? Add. Do I add 1.8 to 1? I add 0.018. So it's 1.018.